Hey everyone, welcome to this series of NumPy. So on this series, we will be learning about NumPy, all the important thing that is needed for data analytics and machine learning. So because NumPy is a Python library, which is very vast library, right? So it could have lot of function, lot of thing, right? So we will be only talking about the function, the method, the only concept that is being constantly used in the data analysis and machine learning part. So right, according to this, right, we will be making this series. So this series will contain everything, right, from basic to everything. So let's start with right. So let me tell you, right, let me show you this thing, right. So introduction, right. So what is NumPy? So NumPy, right, is a Python library, as I told you, right. But the important thing about this is that, right, it is not written Python, right. It is written in C language. That's why it is faster than other thing, right. So that's why the whole NumPy concept comes in, right. So NumPy is a numerical computation language, right. So because like we know, ML is all about maths, right. To perform any mathematical operation, we use NumPy library, right? For that, the concept is NumPy comes into picture, right? And now because like also another thing that NumPy have is a data structure called array, right? So as in Python, right, we have list as a data structure, but in NumPy array we have something similar to the list, but much faster and memory efficient and more another concept including into it, right? So that data structure called array. So it has n dimensional array into it, right? So yeah, this is the thing. So right, so we have these three things. One is it is written in C language, which because of this it is faster. Second is memory efficient. As I told you, right, we use data structure called array, which is memory efficient, better memory optimized version of like a list, right? And another is the vectorization. I will tell it about. I will like explain it later part of it, right? So let me show you, right? This is the Python list, right? So here, like in Python, right? In Python list, right? If you want to multiply or do any mathematical operation to the elements of list, right? So you have to go with the loop, right? But right, this is how you do it. So let me start with this is all about that list, right? In the Python list. So let's introduce with the NumPy array, right? What is NumPy and all that thing. So before anything, right, let's import NumPy array. So before importing NumPy array, you have to install NumPy array first, right? So how to install NumPy array? So I have already installed it through the command prompt. You can install through the command prompt. Second, you can install through the Jupyter Notebook also. So those who have not installed, you can use this command pip install NumPy, right? So run this command and you will able to install the NumPy array. So I have already installed, so I will not run this. So importing NumPy, you can use import NumPy. This is the command. This is how you will install NumPy. So because we will be using NumPy constantly in this video, in this our project and everything, right? So therefore we actually rename it. So for renaming, you can use alias that is called as.as and np. So now every time we want to use NumPy library, you can use np, right? So let me show you, right? So this is the thing, right. We have installed, let me run this cell. So now we have installed the NumPy or import the NumPy array. Now let me show you what is the vectorization means. So as I told you, right, in Python list, if I want to do some operation with the each element of a list, right, I need to create a loop, right. This is how here we have run a loop, and let me print the b. So you can see each of the element of B is being each of the element of A is multiplied with 2 and written in the list B. So this is the B, but let me create a NumPy array. So let me create array equals to how to create NumPy array. You can also see here, right? So np.array function is used to create the NumPy array. So here you can add list here, right. You can add a list here. So here the list above is already there, right. So A is a list, right. I have added list there. So if I want to multiply 2 with this NumPy array, I don't have to run the loop. I can just multiply anything with the array. It will be multiplied with the each element of the array. This is the concept of vectorization. What it means, right? Like if you want to perform any operation with the array, right, each element of the array, you can just perform it with the array. It will automatically perform with each element of the array. This is the concept of vectorization. That's make it like so efficient. Like we don't need to run loop. It can be performed in big of one time, while if we have to run it for the n element for the loop, it will be done performing a big of n time. Don't worry about this time on all things, right. First you can understand this thing, like how vectorization, what does it of vectorization, and everything how it is happening, right. So you have to focus on this thing, right, how NumPy is like memory efficient and how it is faster, right. So we have come to this conclusion that NumPy array is faster than NumPy Python list, right? Okay. Now, okay, moving forward, right? So let's create NumPy array, right? So to create NumPy array, as I already used this np.array, so this is one of the common used function that we will be using in the whole video or whole project and everywhere. So that is called numpy.array function, right? So to create a NumPy array, let me create a NumPy array. Let array equals to np.array, right? And I here mention that list to NumPy. So actually, you have to put the list over here, as I already shown you the example. For now, we will create our NumPy array here. So let me show you how to create array and how to convert list to the array, right? So let me create a list here. First, let me create a list. List equals to, this is how we create the list. Already, I think you already know in Python. And one more thing is that, right, list can have multiple data type, right? But NumPy array cannot have multiple data type. This is one of the important thing. And here you can put the list, and let me show you, right? So here you can see the list is now converted into NumPy array. I can show you the data type of it, right? Print data type, sorry, type, forget type array. So you can see it is a ndarray ndarray. So now the list is converted into the NumPy array, right? So how to create 1D array? So the concept of arrays 1D, 2D, I will let me tell you. This is the thing, right? Okay. So right, this is actually the 1D array. This is the 2D array. It has 2 rows, right, and 3 columns, right? So shape of this is 2 comma 3, right? Or this is the 3D array, right? How the shape is there, right? So we have actually 2 blocks. These are the 2 blocks, right? We have 2 blocks, block 1 and block 2. 2 blocks containing what? Containing 3 rows, 1 row, 2 row, 3 row, and having 4 columns. Column 1, column 2, column 3, and column. This is how we have, this is the visualization of this 3D array, right? Let me tell you with another example how it looks like in this concept, in this function. So if we want to create an NP array, ND array, right, NumPy array with 3 dimension. So here is the thing, right? So shape of this array is we have 2 blocks. We have 2 blocks and we have 2 rows, row 1 and row 2. We have 2 rows with 2 columns, column 1 and column 2. So this is this is the shape of this array, right? So yeah, let's move towards next part. So as I already told you, right, all the NumPy is very important. You can see here it is faster than Python list, right? Everything. And obviously it has n-dimensional capability, right? You can create n-dimensional array into it, right? And as I already told you, right, how loops takes too much time complexity than the NumPy array. So that's why I never use the loop, use NumPy array, right? So now moving towards the creating of array, right? So we were here, right? So if I want to create a NumPy array with 1 dimension, so I can create like this np.array, and here the 1, 3, 4, and here this is the 1D array, right? So let me print it. So this is, you can see we have created the 1D array. If I want to create the 2D array, how you can create it? It is also simple, np.array. Here 2, 3, 4, 5, 6, 7. So this is how you can create 2D array. Okay. Now we have another options to create array, right? So let me tell you, right, if you wanted to create a array, a matrix that is actually containing only zeros, so you can use np.zeros, right? So we have, let's say, np.zeros, and I want to create a matrix of 3 cross 4, right? So I can write it like 3 rows and 4 columns. So now we have a matrix array of 3 rows containing row 1, row 2, row 3, and 4 column, right? And all having a 0. Let me let if I want to have a array containing only ones, not the 0. So we have also a method called np.ones, right? And we can also have here, let me tell you, right, 2 cross 4 matrix. Here you have the array containing only ones, right? This is how you create the NumPy array with the containing only ones, right? Now moving towards the next part, right? So let if you want to create a matrix containing only with 7, like any random number, right? Not only 7, any number. We have seen that how to create a array containing 0. We have seen the how to create a array containing only ones, right? Let if you want to create a array, a matrix that only contains 5 random numbers. So this is how you can create. You can have the function called full, np.full. And here, if what kind of matrix you need, or 5 cross 3 matrix containing what? Containing 7, right? So now you will have a matrix of 5 rows, 3 columns containing only 7, right? This is how you create the matrix, right? Containing a random number that you wanted, right? Now moving towards, right, np.arrange and np.linspace. So right, if you want to create a array, right, if you want to create a array, np.array, let me show you, right, first what it does, then I will explain what it actually doing, right? So np.arrange, and if I write, right, if I write 30, right, so what it will do, right, it is actually doing, right, it is like a range function like in our Python. So what it doing is that it is using uh first item as a 0 and moving towards the 29, right? So this number is exclusive. It gives the range, it fills the array with the range, right? So this is what it does, arrange function. And let me show you, right, if I wait like this, 3 comma 20, right? Now what it will give, uh, you can see here, from 3 is a starting point to the 19 point, right? Because 20 is exclusive, as it is also in the range function, right? So this is what it range function does, right? Now we have a line space function. So let me show you, right, what a line space function does, right? So we have an example. With an example, we will learn it, right? np dot line space, second line space 0 comma 99 comma 10. So you can see here what it doing, right? It is actually giving us 10 values between 0 comma 99 with a gap of 10. This is what it actually doing, right? It gives n evenly space point between start to the stop, right? You can see the difference between 0 and 11, right? Here the 10 gap of 10 values, right? Here you can see also there is a gap of 10 values. So this is what it does, right? Line space. And if you want, right, identity matrix in here, right? So NumPy also have a function called np.eye. Let me show you this thing. So what it will do, it will create a 3 cross 3 matrix, actually a identity matrix, a 3 cross 3 identity matrix. You can see here, you have seen this thing, right? If I want to create np.eye, a 12 cross 12 matrix, a 12 cross 12 identity matrix. So here a 12 cross 12 identity matrix is there. What if I want to shift this 1 to the 1 place or 2 place or 3? What it means? You can use this I function like this also, np.eye. So we have this thing 12, we have this thing 12 comma k is equals to 3. Let me show you what it does, right? It actually shifted 1, the diagonal element, to the three places, right? So you can see diagonal element is shifted. So this is how you can use it, right? So we have another method also called np.empty. What it does, it is let me tell you, let me show you first. So it has actually what it does, what it did, right? It have like empty means like it is giving nothing it is actually giving us the garbage value, right? Any the undeleted value of the data in our memory, it is presenting that to us, right? So it actually helped Python not to initialize anything, right? It is not initializing any array. It is actually giving the values which is already present in our storage, right? So this is how the empty function works, right? and it is very important, right? If you want to initialize any array, right, in any matrix, anything, and you will sure that you will replace every value of it later on the part, right? So why to initialize with zeros, ones, or anything, right? It takes cost of initialization. So what you can do is you can use np.empty method. What it does, it actually get the random garbage value present in the storage and you assign it to the data array, right? It is not initializing anything. That's the important concept of this empty. So now we will move towards the another part in the next video, where we will learn about, right, indexing, slicing, and reshaping. In today's video we have learned all these things. You can take a screenshot or you can revise it, right? Meet in our next video. Thank you.